Hello and welcome to area models. This is actually a topic that we studied last year in Integrated 1, but it is one that's going to keep coming back and keep coming back. So let's refresh here. When we have the area of a rectangle, that can be expressed or written in two different ways. You can write it as a product, which to find product of the area of a rectangle is just length times width. Or you can write it as a sum where you're adding up all the space that's inside of it. So something like this, product and sum. If we have this kind of a tile, right? And we've got our x squared, usually goes in the bottom left. Oh, here we go. Okay. We've got an x squared, we've got a bunch of x's, and we've got some ones. Right? So one way we could write it is we could look at what's the length times the width. This length here is this length is an x block, and this is a 1. So together they make x plus 1. The bottom, this we have x, and then 1, 2, 3, 4, 5, 6 is the width there. So this width on the bottom is x plus 6. So we could write this as a product. Remember, product just means multiplied. And so if I wanted to multiply length times width, the length is x plus 1, and the width is x plus 6. So that's one way I could express. That would be the area of this rectangle that's the inside. The other way we could write it, though, is we could say, let's add up all the pieces on the inside. What is it we have in here? Well, we've got an x squared. We've got 1, 2, 3, 4, 5, 6, 7 x's. And we've got 1, 2, 3, 4, 5, 6 ones. So we've got, this is the sum, this is the product, which means these things have to be equal to each other because they're both representing the same thing. They're both representing the area of that rectangle. Hopefully that makes sense. Now an area model is kind of a shortcut. It enables to represent the same thing without actually using tiles. So this is the representation. And if you see, we can normally just split this and say, okay, let's make sections. 4 sections. The bottom section is x squared. The top left is x. Up here we have 6 ones, and down here we have 6 x's. This side is an x plus 1. This side is an x plus 6. So it's the same thing. This is really the shortcut picture of the tiles. It's called an area model. Okay? So here we have the area of a rectangle, and we want to write it as a product and as a sum. So let's think about product first. This is going to be x, 1, and 1. So total here is x plus 2. So the length is x plus 2. And the width is going to be x and another x and 1 is the width. So that makes 2 x's plus 1. Now my sum is just the part on the inside. I've got 2 x squareds. I have 1, 2, 3, 4, 5 x's. And I've got 2 ones. Boom. There it is. Draw an area model. This should be an area model. Okay, so let's split this. I'll do it like this. Boom, boom. Bottom left I have 2 x squareds. Top left I have 4 x's. Top right I have 2 1's. Bottom left I have 1 x. And along the side I've got x plus 2. And I've got 2x plus 1. Now one of the things that should happen, if I did it right, is that these should multiply to give me this. X times 2x is 2x squared. 2x times 2 is 4x. 2 times 1 is 2. And 1 times x is x. These should all be correct. Alright, go ahead and pause the video and try this one. Unpause, here we go. Let's check your answer. We've got my product here to start, and that is we've got x, x, and 1, which gives me this length is 2x plus 1. Down here I've got x, 1, and 1, which is x plus 2. So we've got 2x plus 1 times x plus 2. Is that the same thing we had up here? Oh man, I made the same problem. I just turned it. Oops. That's weird. Alright, so we got our sum. What happened there? Why did I do that? So I got my sum, which is the part on the inside. I have 2x squareds. And I've got 5 x's. And I've got 2 1's. Is that really the same problem? Oh, that's a shame. This should be really easy then, doing the same thing. Now I'm going to split this here so that the same stuff goes together. So now this is a 2x squared and an x and a 2 and a 2x. And then down here is x plus 2 and I have 2x plus 1. That is area models, sums and products. Have a great day.